Welcome to part 2 of the lecture on pets, and specifically this section will go over deeper. That looks tricky, but they involve square roots, rationalizing, or even arithmetic manipulation. And these show up occasionally in Algara. If you understand the pattern, they become very easy to solve. Let's begin. So far, we handled limits where factoring solved the problem. But sometimes even square roots are involved. Factoring alone does not work. In those cases, we use a powerful technique called rationalizing. Let me show you a structure of this and how it works. If you try to substitute x equals to 4, the top becomes, which is 0 over 0. So we get the indeterminate. But here there is no easy factorization. So we rationalize the numerator. What does that mean? We multiply the top and bottom by the conjugate of the numerator. The conjugate means you just change the sign of the second entry or whatever the sign is there in the middle. So that means if in the numerator you have square root of x minus 2, you just change that sign into a positive and multiply and divide by that expression. That is rationalizing. So the numerator becomes a plus b times a minus b, which equals to a square minus b square formula. But in the denominator, you actually have to multiply, or you can just state it as it is for now, as there might be some cancellations. And yes, the substitution at the end, it gives you the answer. Once you do this one time, every square root limit looks the same. Let's do another one. Exact same idea. Multiply by the conjugate, cancel that's minus 9, substitute, done. And the final answer 1 over 3 plus 3, 1 over 6. So rationalizing is one method you must know because LGAT likes to show at least one root-based simplification somewhere in the functions or algebra. Now, oops, let's look at a slightly more algebraic limit. Sometimes LGAT gives you something like substitute and you will get 0 over 0. As for this question, you need to know the difference of cube formula. And since the formula is a minus b times a squared plus 2 plus ab b squared, this is the expression we have. And after simplification and substitution, we get drop. Again, same concept, different disguise. Now I want you to show one more structure that sometimes appears. Again, substitution gives 0 over 0, but instead of rationalizing the numerator, we rationalize the denominator this time. It is because the square root is a denominator. So multiply and divide by the conjugate of the denominator, which means change this sign in the middle and got expression. The rest of the multiplication is very similar to what we did earlier, but stay alert because now we have the difference of squares formula in the denominator. And after the substitution, you get 2. So now you know both versions of the rationalizing trick. Rationalize the numerator versus the denominator, depending on which one helps cancel the 0 by 0. And especially, the shortcut is whichever has the roots, just take the complex conjugate of that expression.